Hey, 8th graders, today's lesson is 1.5 force in motion, and this is probably one of my favorite lessons as far as the simulation you guys do, because you guys have 8 challenge missions to go over where you guys have to control the force that you exert on an object to change its velocity in a specific manner to hit a target. And the target will only suck up the puck if you guys do it correctly. So it's kind of a fun little challenge for you guys to try to figure out how to tweak these forces in order to get the exact change of velocity that you're required to. Okay, so with that being said, your learning target for today, I can demonstrate how different forces cause different changes in velocity. All right, your very first activity for today is, of course, your notebook. You guys need to add in friction to your vocab page and key concept number 3 into your key concepts page. So let's go ahead, take a look. I have my force in motion section. Vocab, I've added friction right here. A force between an object and the surface it is moving over. So generally that force works in the opposite direction as the force you guys are putting on it to make it move. So if you're pushing an object to, I guess, left for you guys, then the force of friction is going to be working opposite or to the right. Okay, so that's friction. And then your key concept for today is key concept number 3. A stronger force can cause a greater change in velocity, and you guys really started to explore that yesterday with 1.4 when you guys did the little plunger activity and looked at racing your little jar lids using different forces. Okay? All right, so moving back in, you guys have a warm-up to complete on slide 3. So a little friction warm-up, review the definition of friction, consider the 2 events, and answer the question. So again, friction is a force between an object and the surface it is moving over. So imagine you push a book across an incredibly slippery surface, ice, whatever the case. It slides right across because there is no friction. Yet, next you push the same book across a rougher surface, maybe some carpet, that exerts friction. So answer these 2 questions here. Will the velocity of the book change, or will it be constant? Think of those balanced and unbalanced forces as it moves across the surface with no friction. Again, for this, we're going to assume 0 friction whatsoever. Okay, explain again. Think about what we've been learning about with balanced forces and what change of velocity we'll see there, or lack of change of velocity, or unbalanced forces and what kind of change we'll see there as far as movement and velocity. Okay, and then will the velocity of the book change or be constant as it moves across the surface with friction? So that would be like the carpeted surface. And again, think about those balanced and unbalanced forces and what we can expect for either a constant or changing velocity. Okay, remember, pauses you guys need. So once you guys are done with that, you guys can come back in to this video and we'll move on to the sim. All right, so this is activity 3. It is the sim mission. You guys will notice your sim link right here, so you guys can go ahead, right click and open that up. And I'll go ahead and explain the sim with you guys, and then I'm gonna do 2 examples to show you guys how to work this and how to fill out the table. Okay, so work with a partner to conduct. Obviously you guys are at home, so you guys will just be working by yourself. To conduct a series of sim missions, there's 8 of them, that will make objects reach their targets at a specified velocity. So basically you guys are going to start with a specified velocity, and your goal is to get it into the target at a specific velocity as well. Your challenge is to complete each mission by exerting a force on the object only once. So you guys only get to prepare a force and add a force once. That force can be of any size or direction, but obviously it has to be the correct size or direction. Otherwise, you guys will not be able to accomplish the mission. And again, the mission is to make the little target swallow the puck. Okay, so you guys will open the sim. You guys will select the first mission, which I'm going to do for you guys. It's the 1.5 mission 1. So you guys will see that over on this sideboard here. Go ahead and click 1.5 mission 1. Okay, so what you guys will get out of this is, first off, you guys will see in the next data table, or the data tables on the next 2 slides, what your initial velocity is. Okay, if we're just looking at this right now, we have no indications that there's any velocity right now, so we're going to assume that it's starting off stopped. It doesn't have a velocity at all. The velocity is 0. Okay, select the first mission and read the mission task. Your mission task is right here at the top. Hit the target with the horizontal means left to right, velocity of 2 centimeters per second by exerting a force only once. Remember, on all 8 of these missions, you only get to exert 1 force. Okay, you get to prepare a force, You guys can click the buttons as much as you guys need, but you only get to do that and exert that force once. Again, you can change the size of your force. You just can't do more than one force to get it to work. Okay? Press run and then press prepare force to pause the sim while you set up your force. And again, you may have to pause your sim at a specific point. With this one that's not moving, it really doesn't matter where we pause our sim, but on mission 5, which I'm going to show you guys here in a second, it does matter where you guys pause your sim. Okay, use the arrows in the force panel to set up a single force for the object that will cause the correct velocity change. Press exert force and observe the results. If the mission is a success, the object will disappear into the little target. When you succeed at a mission, press analyze and record the strength of the force and the object's change in velocity in the data table. And again, I'll show you guys where to find those. Okay, repeat steps 2 through 7 for each mission and then answer the question. But here are some tips for you guys. So you do not have to prepare your forces immediately. Again, some of those you might have to wait until a specific point to pause that and prepare the forces. Okay, sometimes it's better to wait until the right moment. Compare the object's initial velocity to the velocity shown on the target. This will give you a hint about how strong your force should be. And we're going to kind of use some number lines. Or if you guys are struggling figuring out how many times you need to click your force to see how big your force should be to prepare, I'm going to show you guys a little trick with number lines to kind of help you figure out what you're going. The last tip I would like to add to this, though, is that you guys need to remember that if the force is moving to the left, you guys are going to see a negative, or excuse me, if the object's moving to the left, you're going to see a negative velocity. If it's moving to the right, you're going to see a positive velocity. So keep that in mind because you guys will see that in these sim missions. All right, let's do the first one together. So what you guys see in this data table that you will need to know before you start is what your object's initial velocity is. So right now, if we look at our object, it has an initial velocity of 0 centimeters per second, meaning our object is not moving. Okay, so our goal then is to hit the target with a horizontal velocity of 2 centimeters per second. So we're not moving right now, but we need to hit this target going 2 centimeters per second. Notice it's a positive number, so that obviously means that we're moving to the right. Okay, and obviously the target is to the right, but that's not always going to be the case, and I'll let that be a hint for you guys. All right, so what we're going to do is we're going to click run, and then what we're going to do from there is, since it's not moving, it really doesn't matter when you guys hit prepare your force. You're going to click prepare force. We're stopped right now. We're at 0 centimeters per second, and we need to go to 2 centimeters per second. So we need to change our velocity by 2 centimeters per second. Okay? One click is 1 centimeter per second. So to get it to change to 2 centimeters per second, I'm going to click it twice. Okay, so there's my size of my force. It's going to be a force exerted to the right. And that should, if this works, allow our target or our puck to slide over the target and then get sucked in by the target going 2 centimeters per second. So then I'm going to go ahead and click exert force and watch and see what happens. Okay, so we completed that mission because the little target ate our puck. Okay, so what you guys will do then is you'll hit analyze. First thing you guys will do is you guys will need to record some information. So the change in velocity, this object was stopped and we made it move. So here we're going to put start. Okay, we made our object start moving. Okay, the force direction was to the right. Our force strength, that's something that we need to go into our analyze to do. So we're going to drag this little timeline back to the point where we exerted our force. And we're going to look and say, all right, our force that we exerted was 20 newtons. Okay, so you're looking for that little number on the pink arrow. So 20 newtons, and then your change in velocity you're also going to find from the analyze. We're going to look right here and say, all right, started out at 0 centimeters per second. It currently hit the target at 2 centimeters per second, so our change is going to be 2 centimeters per second. Sorry, I keep going into the wrong thing. So 2 centimeters per second. Okay, so that's how you guys would fill out that first one. Okay, I'm also going to do number 5 for you guys because that one's a little bit trickier. So to get into number 5, I'm going to go back up to my little hamburger bun or whatever you guys want to call it up here, and I'm going to go ahead and select 1.5 mission 5. Okay, so let's take a look at this. I'm going to move my little picture here. Hit the target with a horizontal velocity of 2 centimeters per second by exerting a force only once. Again, I only get to prepare and exert one force. Okay, notice that my puck is moving. So what we need to do is go back to our table and figure out what our initial velocity is. So this is moving 3 centimeters per second to the left, or we could call this negative 3 centimeters per second. Okay, so remember that if it's moving to the left, we're going to consider a negative velocity. Okay, so negative 3 centimeters per second, but it wants us to hit our target at 2 centimeters per second to the right. Notice this is a positive value. Again, let me say that one more time. If your puck is moving to the left, we're going to consider that a negative velocity. So if this number right here was negative 2 centimeters per second, we would have our puck moving to the left. It would go negative 2 centimeters per second, and it would hit that target and go right in. But this velocity that it requires, or your final velocity, needs to be positive 2 centimeters per second, meaning that our object needs to be moving to the right. So right now it's moving to the left, so we need to let our puck drive over top of the target. We're going to stop it here, and then we're going to reverse the direction of our puck to put it back into that hole moving to the right at 2 centimeters per second. So let's talk about this as far as a number line goes. Okay, I'm going to go ahead and just show you guys on an example what I'm talking about when I mean a number line. Okay, so I'm going to use my draw tool. I'm going to draw out a little number line for you guys. All right, so for this number line, okay, our goal is to go 2 centimeters per second to the right. Okay, that's a positive value. And we're starting out going negative 3 because we are moving to the left. So what we're going to do is kind of do a number line. This would be negative 2, negative 1, 0, 1, and then positive 2. Okay, so again, we're starting at negative 3. We want to go to a positive 2. So we need to see how much force to apply to that to get to this 2 centimeter per second velocity moving to the right. So if we're here, we're going to go 1, 2, 3, and that's going to stop our puck. We're going to do another 1, 2 to get to 2 meters per second. So that's a total of 50 newtons of force. Okay, every click you guys do, it's 10 newtons. Okay, all right, so let's go ahead and test that out. So we're going to want to click it 5 times to the right. So again, we're going to pause it after the fact, click it 5 times to the right, and then it should hit our target going a positive 2 to the right. So let's try that. All right, we're going to hit, I'm going to move this guy first. We're going to hit run. We're going to wait until it passes the target and hit prepare force. Okay, and then we're going to go ahead and prepare our force. Remember, we said that we have to go click it 3 times to the right to stop the puck. 1, 2, 3. And then another 2 times to get it moving again and moving to the right 2 centimeters per second. 1, 2. Okay, so then go ahead, exert that force. And we just sucked up our puck going 2 centimeters per second to the right when it was initially moving 3 centimeters per second to the left. Okay, if we go into our analyze, we can get our data for this table. Okay, so for this we have 3 centimeters per second to the left, or negative 3 centimeters per second, however you guys want to put it. Okay, our big change to our velocity is going to be a change in direction. So I'm going to put in there change direction. Our force direction, we actually added that force to the right. Okay, it was moving left. We needed to add a force to the right to get it to stop and turn around and go in the other direction. Our force strength we're going to get from our analyze. Again, we need to kind of click and drag this. Remember, every time we click the little exert force button, we're adding 10 newtons of force. So you guys can see our little pink arrow amounts to 50 newtons of force. So I'm going to go ahead and put in 50 newtons here. And finally, our change in velocity, again, we're going to get from analyze right here. We have a change in velocity of 5 centimeters per second. So 5 centimeters per second. Okay, so that's your guys' data for the first, not the first 2, but mission 1 and mission 5. You guys also have to complete missions 2, 3, and 4. And then on the next slide, missions 6, 7, and 8. You guys will see another one where you have to turn it around. You guys will also see somewhere you need to stop it right on the target and get that puck to stop. So again, you guys can kind of use a number line. If my puck is moving a certain speed, how many clicks do we need to get it back to 0? Because 0 would be stopped. Okay, so if you guys have to use a little piece of scratch paper or a marker board to figure out your little number line, if you guys can't figure that out in your head, that's totally okay. Okay, so I'm going to go ahead and delete those, and then I'm going to show you guys the next section. So again, pause this video, take a couple minutes, go through, finish those sim missions, okay, try your best on them. If you guys don't get it right the first time, go back to the drawing board, okay, figure it out. Okay, finish the sim missions and then answer this question. What do you notice about the relationship between force strength and the size of the velocity change? So you guys will look at force strength here and your velocity change. Notice we have one that's 20 and one that's 50, one that shows a 2 centimeter per second change in velocity and one that shows a 5 centimeter per second change in velocity. So what kind of relationship do you guys notice between those? As we move from 20 newtons to 50 newtons, what happens to our change in velocity? Okay? Answer that question, and again, when you're ready, we'll move on to the modeling tool. Okay, so this is the activity for modeling. I'm going to show you guys first how to use the modeling tool, and it's really important that you guys understand how to use this because on lesson 1.6, which is coming up next week, if this is 2021, then you guys will be using the modeling tool for a quiz grade. So you guys will be graded on how well you understand how to use that modeling tool. So really make sure you guys focus in and understand what you're doing today, starting right now. Okay, so first and foremost, you guys will need to open up this modeling tool link so you guys can go ahead and right click it. It's gonna look like this, okay? This one's already reset for me. What you guys see is we have 3 boxes right here. We have a before force, so what was our motion looking like before? In this case, we're just going to be focusing on modeling the force, okay? So our little puck was not moving to start. Its initial velocity was 0, okay? Then we're going to apply a force, and you guys will use kind of the little word bank here to drag an arrow to show which direction the force is to cause this change. So after we apply the force, we see that the puck is moving. Notice that the little lines behind it kind of suggest that it's moving to the right. And if we kind of compare, it's moving to the right at a medium velocity. Okay, so you guys can kind of see this is what a slow velocity would look like. Here's a medium velocity, and here's what a fast velocity would look like. Okay, again, you guys are just going to be modeling the force. So here are your arrow options for force. You guys could have small forces to either the left or the right. You can have medium forces to either the left or the right. And you guys can have large forces to either the left or the right. So what I want you guys to do right now is I want you to pause this video and I want you guys to choose which arrow you would use to represent your force to get this object that was stopped to start moving at a medium velocity. So you guys want to pick the right direction of the force and you guys want to pick the right size of the force. So again, go ahead, pause this video, do that now, and then we're going to take a look to see if you guys are correct. All right, so again, you guys have this puck that is not moving. We're going to apply a certain force to it, and then after that force is applied, we're going to see the puck moving to the right with a medium velocity. So you guys should have put on there, doesn't matter which side you guys put it on, you guys can either put it over here or you guys can put it over here. You should have chose a medium-sized force, and you guys should have had that force moving to the right. So that's going to cause our puck, which was stopped, to start moving to the right with the medium force. So basically you guys just exerted an unbalanced force on that puck, causing it to start moving with a medium velocity. So if you guys modeled like this, you guys use that medium arrow to the right, you were correct. Again, it doesn't matter which side you guys put that arrow on, that still works. It shows that you're applying a force to the right and it's a medium-sized force. Okay, great job with that. There's nothing you guys need to do as far as handing that in or screenshotting it. We're gonna go ahead and move on to the next section of this. Okay, we're gonna do a little bit more practice, and I'm gonna use your draw tool just to show you guys how this would look. Okay, so some more examples for you guys. We have an object that is moving, and then we're gonna apply some force to it, and then we're gonna see an object moving a little bit faster. Okay, so if we kind of look, it looks like this object was moving with a small velocity to the right. We're gonna apply a force to it, and now it's moving with what looks like a medium velocity to the right. So what can you infer about the strength of the force exerted on object A versus object B? So let's take a look at object B. Okay, object B was also moving with the same small velocity to the right as object A. We applied a force on it, but afterwards, okay, notice how our object after the force is not moving as fast as object A. Okay, so what can you guys infer about the strength of the force on A versus B? Which one had a greater force, A or B? Think about their movement after. Okay, let's take a look. All right, so before the force, for A, we can see that it's moving with a small velocity to the right, same with B. Notice how A has a larger force arrow on it, meaning that we added a larger force to A to cause this larger change in velocity. So after the force, A is moving quicker, okay? B is going to be our smaller of the two forces. So if you guys said that A had the larger force, you're correct. If you guys said that B had the smaller force, you're correct, okay? Those two forces are going to cause these appropriate change in velocity. So these arrows show that a stronger force was exerted on object A, and that object A was then speeding up more than object B because of that. Okay? All right, final little section for you guys. You guys are going to practice this modeling in a different modeling tool. So you guys will need to open up this different modeling tool. It is not the same as the one you guys used before. So I'm going to go ahead, open it up. This one is called Different Velocity Changes. So what you guys are going to be doing is modeling the velocity changes to cause different changes in velocities that you'll see. So you'll have 3 examples of what you guys will need to do. Okay, so you guys can see all 3 of our examples. We are moving to the right with what looks to be a medium force. I can kind of click and drag to compare. You guys are going to be modeling the force arrows to cause these changes in velocity. So the first example, we're moving to the right with a medium force. And then after the force occurs, it looks like we slow down and we're only moving to the right with a small force. So you guys need to think of what size force and in what direction of arrow would you guys use during the force, okay? If our object is slowing down, okay, we need to be applying a force in the opposite direction. It only slows down a little bit, so from medium to slow velocity. So my force would look like this, a small force in the opposite direction, okay? You guys will do the other 2. Again, moving at a medium velocity to right, we're gonna apply a force to it, and this object is gonna stop. So which arrow, okay, which direction are we going to need to apply that force to get it to stop? And then what size of force are we going to need to put on it? If it was moving at a medium speed, are we going to use a small, medium, or large force? And then finally, medium velocity to the right, we're going to apply a force, and that object is going to turn around and move back to the left with an opposite direction and a small velocity. Okay, so again, which direction are you guys going to apply your force, and how big is that force going to need to be, small, medium, or large? So go ahead, finish the modeling tool for these 2 examples. Again, you're just adding the arrows on this during force for this example and this example, and then go ahead and screenshot your modeling tool right here. Once you guys have done that, you are all done. Do your wrap up. Do you have any questions? Circle yes or no. And then 4, 3, 2, 1, how do you think you did? You are all done. You can go ahead and hand it in, and I will talk to you soon. Thanks.